Okay, so we're looking at section 10.3 here, log equations. Now, it's not going to be a big surprise, guys, but by the end of this, you'll be able to solve logarithmic equations. Now, of course, this is going to be heavily relying on these log laws and these couple of little identities here. So this is what we're going to be referring back to when we're solving these equations. So let's get into it. We've got log base 3 of number 81 equals 2x. So I'm just going to convert that 81 so it's 3 to the power of something. So that's 3 to the power of 4. The 4 can be coming down, so I've got 4 lots of log base 3 of 3. And then, of course, log base 3 of 3 will just simplify to being 1. So on the left-hand side, I've got 4. Still on the right-hand side, nothing's been changed, so that's just 2x here. So I've got 2x equals 4. Divide both sides by 2 to give me x equaling 2. B, log base 3 of 5x plus 2 equals 7. So I'm just going to rearrange it. So instead of writing it in log form, I'm going to write it in index form. So my base is 3. And when I raise it to the power of 7, the answer will be 5x plus 2. 3 to the power of 7 is equal to this. I subtract 2 from both sides. And now I divide both sides by 5. Now the process here you should be able to do and be able to answer that kind of question for an exam 1 type of question, but the numbers won't be so large. You know, evaluating what 3 to the power of 7 is, you're going to have to do that by hand, writing a bit of a list out, and then to work out that 2,185 divided by 5 is equal to 437. I mean, that's a lot of just mental computation there. So we won't be wanting to test that. So it's not the best example, but that process you should be able to follow just with smaller numbers. C, we've got log base 4 of 1 on 64 equaling x. So again, recognise that 64 can be written as 4 to the power of something, 4 to the power of 3. Bring it up to the top and write it as a negative power. That negative 3 can come down. And of course, log base 4 of 4 simplifies to being just 1, so I have x equaling negative 3. D, log base 10 of 2x equals 1. Again, reorganise it so it's in index form, so base 10 to the power of 1 will give me 2x. 10 to the power of 1 is just 10. Divide both sides by 2, so x equals 5. E, this time I have 5 to the x equals 8. Now this is an indicial equation, and usually what we'll try and do is get the base on the left to equal the base on the right, but it's going to be impossible for us to rewrite that 8 so it's 5 to the power of something. So this is what I'm going to do. I'm going to take log base 5 of both sides. So I'm doing the same thing to both sides, but the reason I choose log base 5 is because I've got a 5 here. Of course, what will happen now is that my x can come down, and log base 5 of 5 will simplify to being 1. And therefore just x. So when I took log base 5 of both sides, I've just got log base 5 of 8, and that's just flown all the way through. So x is exactly equal to log base 5 of 8, which is approximately equal to 1.29. And of course I evaluate that on the CAS. F. You can see I've got log base 3's in each of these terms. Firstly, let's combine the left and then the right. So log base 3 of 5 minus log base 3 of 4 will become log base 3 of 5 divided by 4. And log base 3 of x minus log base 3 of 8 will become log base 3 of x on 8. Now because I'm doing the log, base 3 of both sides, then I can just simply equate what's inside the brackets of these. So 5 on 4 equals x on 8. Then multiply both sides by 8 and simplify, get x equaling 10. G, log base x plus 1 of 27 equals 3. Again, we're just going to manipulate it, so it's going to be in that index form. So the base is x plus 1. I raise it to the power of 3, and it's equal to 27. I want to strip it so it's just x. So I'm going to take the third root of both sides. So the third root of 27. Now the third root of 27 is positive 3. It's the third root. So what number, when multiplied by itself, 3 times over gives me 27, and that's a 3, positive 3. 3 times 3 is 9, times it by 3 again is positive 27. Take away 1 from both sides, I get x equaling 2. Just a little reminder here about Euler's number. So Euler was a Swiss mathematician, and he found out in science that there was this reoccurring kind of ratio or pattern that kept on occurring, and he referred to that as Euler's number, and it was approximately equal to 2.71. So it's the same kind of thing as pi. You know, pi is approximately equal to 3.142, blah, blah, blah. Euler's number is approximately equal to that. Now, notice on our CAS, it's different than the letter E on our keyboard. It's Euler's number, and I'll show you where that is shortly. Okay, so to begin with this problem, we've got solve 2 lots of log E of 3 plus log E of x equaling 10. So I've got my addition here, and so because they're both log E's, I will be able to do a multiplication eventually. But firstly, I've got the 2, so I'm going to take that to the top. And 3 squared, of course, is 9. So I've got log base E of 9 plus log base E of x. And because I'm adding and got the same bases there, then what I can do is just multiply the 9 times the x. So I've now got log base E of 9x equaling 10. I can rewrite that as being e to the power of 10 equaling 9x. So the base is e. I raise it to the power of 10, and it'll equal 9x. Divide both sides by 9, and I have that e to the 10 on 9 equals x. And that's approximately equal to this figure here. So let's just take a look at that on our CAS. I've got 2 times. Now I don't want this log here. I can go control log. And the E I want to bring up is not this E. Okay, it's this E over here. So let's go this E. That's Euler's number. I don't need to put anything in there. So let's put that in. And it is of 3 plus. Now another way of doing log base E is because log base E comes up in science all the time and in the natural world, it's often referred to as the natural logarithm. So I can just go here, control ln, which stands for the natural logarithm. Ln, so log E of x equals 10. What will that simplify to be? There. Natural log of 9x equaling 10. And that's what we've come up with here, log E of 9x equaling 10. Now, of course, we had to solve, so just to show you, I'm just going to copy that expression. And now go menu, algebra, and solve. and then go Control V to paste it, and I'm solving for x. So just hit enter, and there's my solution. E, Euler's number, to the power of 10 divided by 9. Of course, I could have just gone menu algebra solve and put all of that in. I could have written this as 2 lots of ln 3 plus ln x equaling 10 comma x, or I could have done the log e, but you can just see there that they're all the same. And here I've got ln, which just means log e of 9x equaling 10. And that's equal to 2,447.39. So back on my CAS, if I just go Control Enter, you can see that it gives me the approximate solution, which is the same. Alright, moving on. Here I've got e to the 2x minus 5 lots of e to the x plus 6 equals 0. So here we are. We've done this kind of work before with exponentials, but I can think of that as being e to the x squared, so it's just broken that up. We know that if I were to now expand that out, just simply go x times 2, so that's the same thing, minus 5 lots of e to the x plus 6. So basically what I've got is some junk squared minus 5 lots of junk plus 6 equaling 0. So I should be able to recognise that that's a quadratic. So I make the substitution that u is equal to e to the x. So I have u squared minus 5u plus 6 equals 0. I can factorise that as being u minus 3 being multiplied by u minus 2 equaling 0. Applying the null factor law, u take 3 equals 0 or u minus 2 equals 0. So I have u equaling 3 or u equaling 2. Given that u is equal to e to the x, I have e to the x equaling 3, e to the x equaling 2. Just working on the left-hand side here. If I now take log e of both sides, I'll have log e of e to the x equals log e of 3. The x can come down. Log e of e will just become 1. So I have x equaling log e of 3. On the right-hand side, I've got e to the x equaling 2. I take log e of both sides, and the reason I take log e of both sides is that this left-hand side here will collapse to become just x. So I take log e of both sides. The x, of course, comes down. Log e of e just becomes 1, leaving with just x. So I've got log e of 2 is what it's equal to. And I can do the same thing here with my CAS. Put all that info in. You've seen how I've done it. Notice the solutions come up with ln 2, just means log e of 2, and ln 3, which just means log e of 3.